Hello, everyone. Fantastic to be here, and even better to see you on Kubernetes presentation at a Java conference. So that's always a challenge. Today, we are going to talk about privilege escalation in Kubernetes. It's not going to be much about theory. We are going to focus on practice and live hacking. So I will need your help here. Okay, so get ready for a ride. But first, a brief introduction. I've been doing professional software development for over 20 years. Often I feel like a dinosaur, especially among you young developers. I was always very much into code, and this bond thrives today as well. However, over 3 years ago, I joined the dark side of platform engineering. And guess what? I absolutely loved it. So nowadays, I'm a staff SRE engineer at Form3. What do we do at Form3? In short, Form3 is a financial cloud. We provide a payment as a platform model for easy and flexible integration with various payment schemes. Our work model is fully remote with only senior engineers. We are very much technology oriented with our new payment system based on Kubernetes and 3 clouds. So obviously our Kubernetes security is super important to us. What am I going to talk about today? Just a splash of theory to understand what Kubernetes architecture looks like and what actually privilege escalation means. Just for all of us to be on the same page. And then we will quickly move to several demos when I will exploit various security vulnerabilities in Kubernetes clusters as well as applications to hijack your accounts. Before we go to hacking, it's good to understand what we are attacking, right? So when it comes to Kubernetes, there is like 2 main components here, control plane and worker node. Control plane is basically managing Kubernetes clusters. The heart here is API server. So whenever you want to update or create a new resource, you need to go to API server. API server exposes Kubernetes HTTP API. So basically, this API can be used by various tools, including kubectl. Who knows kubectl? Yeah, I guess all of you. Another important component here is etcd. etcd is a key value store where all information on all components in Kubernetes is stored. So basically, if you want to learn anything about Kubernetes resources, you can go to etcd and read it. And on the other hand, we have worker nodes. So basically, worker nodes are the place where the actual work happens. So the pods run over there. And here we have one of the main components, kubelet. Kubelet is responsible for instantiation and execution of pods on a given node. And similarly to the API server, kubelet exposes also an API. So whenever you want, or whenever clusters cluster wants to create or instantiate some new pod, it goes first to kubelet. So sneak peek here, we will attack kubelet to basically get an unauthorized access to our worker nodes. Another thing important when it comes to Kubernetes is its networking model. Kubernetes exposes this flat networking model, which basically means that each pod can communicate with any other pod. And we do have CNI here, which takes an important role. This is a container network interface. This is only an interface. We have several implementations here. And with CNI, basically, CNI providers, they create an overlay network over like regular host network, which allows this pod-to-pod communication. How do they work usually? Usually underneath such CNI providers implementations like Calico, Flannel, they create a series of virtual network interfaces and then use IP tables or eBPF injected rules to route a traffic to a right pod. So here it's important also because we can like target CNIs, those virtual network interfaces, to learn about traffic between pods. So let's move to privilege escalation here. So I'm pretty sure that you know what privilege escalation means. Basically, when a user gains more access or permissions than originally assigned. So we can talk about vertical privilege escalation, which is also called privilege elevation, when a lower privileged user accesses some resources, content, or performs function on behalf of a more higher privileged user like super admin, root, or something like that. We also have this horizontal privilege escalation when we gain access to content or functions of another normal entity. In case of Kubernetes, we can think about privilege escalation in different contexts. First of all, accessing cluster with extended permissions or as a different user entity. And then we can think also in the context of accessing different workloads, data within a cluster. And then we can also talk in terms of privilege escalation, like when we, as hackers, escape to node. So accessing node resources. And then when our Kubernetes clusters are deployed into a cloud or they are like managed offerings, we can talk about escaping to cloud. So accessing cloud resources. And when it comes to threat modeling in Kubernetes, it's not like very detailed area, and only recently, like last couple of years, it became more prominent. So in 2020, Microsoft published this Mitra attack framework, which shows a matrix, threat matrix for Kubernetes. Mitra attack is like an industry standard for modeling threats. It was implemented and introduced long time before Kubernetes by Microsoft in 2020, and then with 2021 update, for the first time introduced something for Kubernetes. We do have a privilege escalation column here, and it says something about privileged containers, cluster admin binding, host path, and accessing cloud-based resources. I don't think it's like a full list of possible threats when it comes to privilege escalation in Kubernetes. So I think it needs some update. I will show you some of those attacks as well as some other approaches. Also in 2022, for the first time, OWASP published this Kubernetes top 10 security risk list. It's like a hit parade, so we can take a look at some of them, especially in the context of privilege escalation. When it comes to privilege escalation, K3 seems super important because it talks about overly permissive RBAC configurations. And when it comes to any privilege escalation, incorrect or missing permission configuration is like the first source of any problems. But it's not all of it. Number one is the source of many problems in Kubernetes, and privilege escalation is one of them, insecure workload configuration. So you can think about running your pods as root. You can think about privileged mode in Kubernetes pod configuration. You can think about writable file systems and many more configuration parameters. Connected to insecure workload configuration is lack of centralized policy enforcement, number 4, because we shouldn't allow to deploy any misconfigured on not securely configured workload to our clusters. So we need some sort of a mechanism to prevent such deployments. Also, when it comes to privilege escalation, cross-workload configuration, cross-workload communication, you can think about K7, missing network segmentation controls, because as I mentioned, Kubernetes exposes this flat network security model, so basically each pod can communicate with any other pod. So if you have different deployments in the same cluster, you need to think about network segmentation yourself. So it's your job to deploy proper network policies to, for example, block any traffic between two namespaces. Obviously, secrets management failure, some leakage of tokens, passwords, or secrets in general can lead to some privilege escalation as well. And obviously, lack of, for example, proper authentication or authorization management, like misconfigured cluster components, can also lead to some privilege escalation. So you see that all those vulnerabilities can be exploited in order to access and gain more privileges when it comes to cluster, node, or actual workloads. Okay, so that's it when it comes to the theory. Let's move to the more practical side. This is gonna be like 101 hacking in Kubernetes. So this is like some basics when it comes to Kubernetes hacking, but hopefully you will see how a series of simple misconfigurations can lead to a total compromise of your entire cluster. So I have this vulnerable demo application. This is available under jdd.yonlabs.com. And here I need your help, please. If you could go to this address and register your accounts. Each account has a secret data, log in and wait to be hacked. On the other side, my objective here is to hack your accounts and learn your secrets. I will give you some time to scan the QR code. As you will see, this is like a simple web-based application. We will take a look at the details. If you want to access the link, it's also available on my X or Twitter account, YonLabs. So you can just see, you can register a new user. I've already registered mine. When you log in, you see like secret data, you see active users. I will wait for you to register. Oh, thank you for your cooperation. So I have extra users to be hacked, so let's start hacking. But before we move to our Kubernetes cluster, because obviously this application is deployed into Kubernetes, let's take a look at authentication, so some session storage. We see that this token looks very much like a JSON Web Token. So let's give it a try and see here. Yes, indeed, this is a JSON Web Token that uses this HS256 algorithm. Basically, this is HMAC with SHA-256. What does it mean? It's very handy for us because it means that this is like symmetric cryptography. So basically, we can attack our accounts in this application by discovering a secret. So basically the secret which is used to encrypt signature. Or we can just, when it comes to, so this is like due to symmetric cryptography, the same secret is used to encrypt and decrypt data. And when it comes to JSON Web Tokens, another vector attack is like to sniff some existing tokens and steal some existing tokens. So those will be like our two ways to attack and hijack your accounts. Two main ones conceptually, but when it comes to technical details, it's gonna differ. Okay, so I will log into my evil cluster. Basically, this evil cluster here, let's assume that we have access to some credentials. So we are a malicious user, like malicious insider, or we got, as a hacker, our hands on existing credentials of Joe Doe user. This Joe Doe user, he doesn't have like any elevated credentials yet. As you can see, he's not able to see nodes, pods, or secrets in a default namespace. However, let's take a look what this user can at all. So let's use kubectl auth cani command. And here it becomes interesting. We have this impersonate privileges. What does it mean? So basically, this privilege means that we can impersonate any other user. So let's give it a try and let's display nodes, nothing crazy yet, as system masters. So basically, we are allowed everything. Okay, we managed to do that. Now, what can we do more? It would be useful to basically see namespaces first. Like we want to see what's deployed. We do see something interesting, like for example, front-end and back-end. It seems like they work together, and this might be our demo application. Okay, I know that this is our demo application, so let's display pods in our backend namespace. We see one pod here. So one more thing, we want to display manifest for this pod, and we want a YAML output. When we take a look at the configuration, we can learn something else. This part is interesting. So basically, we've already seen that our web application uses JSON Web Tokens. They use HA256 algorithm, and I told you that this is a symmetric algorithm. And here, most likely, is our secret. Right, so let's find out the content of this secret. So basically, I want to display secret. That was demo secret. And yep, we got it. How can we use it now? Fortunately, we have this very handy jwt.io page. And we can copy our secret and generate a new token. This user with subject 1, this token with subject 1 credential, this subject usually is used to encode some sort of a user ID or unique identifier, basically, for our user. This is often used, so let's give it a try and try number 4 here. So I need to copy my new token and replace my original token with this new one and refresh the page. And Oleg, you've been hacked. Oleg, are you here? Congratulations, and thank you for such a nice cooperation. Okay, so that was pretty simple. And you've learned about overly permissive RBAC configuration. So like impersonate definitely is not, shouldn't be allowed for any regular user. And this is not the only permission we should be careful about. We should think about create the permission to create new role bindings, because this way we could work around existing permissions. We need to be careful when it comes to listing or getting secrets, as you've seen. And also creation of new pods, deployment, stateful set, daemon set, etc. Together with execution into pod. Those are pretty dangerous. Why? Because it seems like creation of a new pod, like for a given namespace, shouldn't be like a big problem. So I will show you that actually it can lead to a compromise of a cluster. So when it comes to RBAC best practices, we need to think about least privilege principle. This is nothing new, you know that from other areas as well. We can also think about time-based roles or multi-factor authentication. So basically, with time-based roles, a user is assigned a role for a given time period, not like for forever. So this is super useful, and it can depend and be configurable depending on your environment. So for example, when it comes to development, you can relax those parameters and configure 24-hour. When it comes to your production environment and clusters, I guess it shouldn't be more than 2 hours. So let's move to escaping from our pod to node, and I can show you how we can use pod extra permission that allow you to create custom pods. So now I'm still in, no, I'm inside a pod, nope. Okay, I'm on my evil server. Now I want to switch to John user, and let's see if this user can see nodes, kubectl, that's not the right one. Okay, we are not able to see the nodes as this John Doe user. So let's see again what this user can do. And here I know something more, and I will check full app namespace. So fortunately for me, this user is allowed to create pods and deployments in this namespace, as well as is able to exec into pods. Okay, so here I have some manifest prepared. And this manifest basically creates a new pod that is very insecure. Basically, everything's allowed. Like we have host network available, host PID available, host IPC true. We run this pod in privileged mode, and even we mount like a host volume. So you see that's like super insecure. So let me apply this one. And let me exec into this pod. That was full app namespace, and yeah. Okay. So one thing which is also important here, we try to schedule this pod on a control plane. We can find out the node name or IP name from our kubeconfig for our original John Doe user. It shows like a connection string to our control plane. And based on that and the information that this is AWS, you can if you know like naming convention, you can see this is basically AWS. So you see this is like when you try to exploit something, this is a series of simple configurations and a series of like some information, background information you know from different places. So we are on this node, and we can basically search for some, we can search for some leaked credentials. Most likely, admins often leave Kubernetes admin credentials on control planes just to get easy access to those resources. So here we can search for this as well. Let me see my cheat sheet here. I do have a couple of escalation here, but okay, this one is gonna work. So we did find .cube folder. We can give it a try and see if it indeed contains config here. When it comes to okay, we don't have anything here, but when it comes to Ubuntu user, we should have something. And when you see this config, we should see which user it belongs to. Okay, we have Kubernetes admin. That was really handy, right? We don't have kubectl installed here, but let's give it a try. And often it's useful if we have such like high privileges in this pod, we can basically change root to host, and this is like we are on the actual node here. And kubectl here, do we have it? Yes, we have it. So now we need to let me, no, not this one. That was, okay. Basically, we need to export kubeconfig and set it to our actual Kubernetes configuration. And now we are admin. If we are admin, so we've already known that we have the secret we are targeting. So let's get secret. That was demo secret. Output YAML, and namespace was backend. And again, we are here. Let's give it a try and try a different user now. So user number 7, lucky 7, right? Does it work or not? It must. That's the same secret, and undefined, you've been hacked. Another way to approach it, we don't need such broad privileges for that, is to search for etcd database. We are on the node at the moment. Let's find etcd process. We were allowed to be scheduled on a control plane here. So basically, we have access to etcd. Here, what's important is this data dir. So basically, data directory. We can basically display the entire etcd database as this is only a text file. So you see the entire database. Let's grab for registry secret. And we see this demo secret. And here is another way to access this demo secret content. Okay, we got it. Again, I could use it to hack and generate more tokens for lucky user 10. Do we have such a user? I'm not sure how many. Yeah, we do have quite many of you registered, so thank you for this cooperation. Yep, we have Igor Migdał. Are you here? Yeah, thank you. So you've seen here, like, we had many ways to escape to Node and then find out more information with our privileged data. When you want to learn more about Kubernetes pod privilege escalation, I highly recommend this blog post by Seth Art. He describes various problems in Kubernetes workload configuration and how they can be exploited. Here we had like full exposure with root privileged and other misconfiguration. But think about also lack of centralized policy enforcement. Such workloads should be rejected from a cluster. So we need some sort of admission controller which verifies what means secure configuration and rejects any insecure configuration. Also, we had secrets management failure here because you see that by default those data are not encrypted, they are only base 64 encoded, so basically those are plain data. When it comes to escaping to Node, we can also give it a try when we have more secure configuration, but still with a lot of configuration parameters improperly configured. So here I need to leave my control plane. Okay, I'm on my evil server now. I will switch to Jane user. And again, Jane user is not allowed much. Definitely she's not able to see nodes. What can she do? When it comes to full app namespace, not much, but when it comes to bar app, you see that deployments are allowed. But you see that we don't have this exec pod privilege. So we can deploy a new pod, but we can't access it. So it's not as easy as it used to be for our previous demo. So what can we do here? And here there is a standard trick for hackers, reverse shell. What does it mean, reverse shell? When you want to access some remote machine, you basically usually SSH to it, exec into pod with kubectl, something like that. You need to provide your credentials, have permissions, and then you are given a shell. Reverse shell is the other way around. So instead a client machine connecting to a remote machine, this is a remote machine connecting to a client machine, this way bypassing this verification step. So here I have another okay, I have this deployment. So here you see that I use only host PID, I use privileged mode, and so basically my pod is configured this way that it connects back to my evil server. You see that I'm using basically the same IP as assigned to my evil server. So here I need something to connect to. So let me open a second terminal, and basically I will run ncat on port 4444, and you see that my deployment connects to this port and exposes local to this deployment shell, local to the pod resulting from this deployment. Okay, so let's go for it. Let's deploy this one. Okay. That was unchanged deployment. That was existing deployments because I did like a trial run before the presentation to make sure that all the demos work correctly, and I haven't removed this one. But anyway, you see that we do have this connection received back. And what we can do, like some sort of reconnaissance. So we see everything what's in a main folder. We can see if netstat is available. It seems that it's not. Here you don't see sometimes error messages. Why? Because this reverse shell is not a fully interactive shell. And you don't get this redirection of an error stream to an output stream. I had to do it like manually. What can we do here? Let's make sure that indeed we are on this pod. Yes, we are. And here we have access to host PID. So basically we can access all processes as it was like a host namespace. So we can do another trick when it comes to Linux security. We can enter a namespace. We are targeting the process number 1. So basically, this is like the main init process on a given host machine. We are targeting all namespaces. And this should be it. And now you see that our uname changed. Now we see that we are on this actual host. So basically, again, we managed to escape our pod, and we are on the host node. If we are on the host node, we can see all those virtual interfaces I mentioned before. So basically, in this Kubernetes configuration, I use Flannel as CNI. Flannel created those virtual network interfaces. And now I would like to sniff the traffic here. Obviously, it would take me a long time to get meaningful traffic, so I'm cheating a bit because I will use TCP dump only on port 1990. So basically, I know that this port is used by our demo application. So I'm running TCP dump, and my kind request to you, please refresh your pages in our demo application. Did you manage to refresh? Or did I make a mistake? Let me double check. Yep, I need. Let me run this on any interface, not local one. Can you refresh, please? I don't see anything coming. I will refresh myself. And here, this is kind of confusing sometimes because, as I told you, we don't have like fully interactive shell. So I will create this connection once again. It should be. It should connect in a moment because there is a pod running, and I should receive this connection once again in a moment. With with no error messages, it's sometimes difficult to see if you make a mistake, some typo or something like that. So there are some ways to pimp your shell. Oops, yeah. Thank you. Yeah, not the right server. Definitely, I won't connect to this one. Okay, let me wait a little bit. Yeah, I can do something else here. I can just force recreation of this. As you know, I have like pretty limited permissions here, but I do have like some backdoor to my control plane. I will try to force instead of waiting to connect. Yes, because I would need like to wait. Yeah, if it's in crash loop, let's delete this one. And it should connect. Okay. Sorry for this one, but let's make it working. Just not to make any mistake, I will use my cheat sheet then. Because I don't want to have any typo or anything like that. So we are entering our host namespace, and we are on the host now. You've already seen those virtual interfaces, so now let's run TCP dump. Okay, so that was some typo on my side. Okay, so thank you. That's actually pretty intense traffic, and it's too much. We do have, as you see, bearer tokens. So basically, we see any traffic. So let's give it a try and use this this token in our hacking. Refresh. And Kasia123, you've been hacked. Are you here? I don't see, but hopefully you are here. And thank you for your cooperation. Okay, so you've seen that even with like not everything allowed, we could still enter the namespace of the host. Actually, privilege and host PID are pretty like wide permissions, so you definitely need to be very careful when it comes to those configuration parameters. As you see, we have like different sets of permissions that can be configured. If everything allowed, then basically the sky is the limit and full cluster compromise is a given and very simple one. When it comes to privilege and host PID, you've just seen that full cluster compromise is still possible with escape to a node. With privileged only, we can still escape to node, and it means basically full cluster compromise. However, it's not as simple as with host PID. With host PID, this was just one command. Here we need like a more complex set of commands to make it working, but still multiple paths. With host path, still full cluster compromise as a worst case scenario, but usually a host path available means that hackers look for access tokens, kube configs, SSH keys, and that kind of stuff. And then when they have also access to, for example, shadow passwords, they can crack passwords. With host PID only, we are not get to the full cluster compromise, but still some credentials leakage if application misconfigured, for example, if we have some credentials configured in a command line. Because with host PID, we can see all the processes with all the parameters running on a given host. So if we list them and there is some password configuration in a command line, then a hacker can see and pick it up easily. Then denial of service, because once a hacker gets access to all the processes, they can terminate whatever process they want. With host network, usually hackers go for traffic sniffing, accessing services on local hosts, and this way bypassing network policies. So you see that still this is not safe. Host IPC, this is usually pretty safe depending on inter-process communication we have in our cluster. Nothing allowed, it seems like, obviously this is the safest solution, but it doesn't mean that your workloads are safe in your clusters. So still with super secure configuration, some bad things can happen, but it requires a lot of more work and some other misconfigurations in your clusters. So I think that we don't have time for our last demo. Apologies for this because I was pretty stuck with those typos. The last demo was about discovering unsecured kubelet API in our cluster and then making use of it. As you see, by default, Kubernetes provides anonymous auth and authorization mode, always allow in your clusters. But this is not as simple as it sounds, because usually you don't use like custom Kubernetes installation, you use like more proven installation methods, or even you use managed Kubernetes. So this does not apply to managed Kubernetes in clouds. Those have very secure configuration and control plane, and kubelet API is secured. Even if you install your clusters on bare metal machines, but via, for example, kubeADM, this is secure. So this must be like really old installation or very unorthodox installation to have those defaults. When it comes to Kubernetes, security is just the top of a very, very huge iceberg. So I could go on, and fortunately or unfortunately for you, I'm out of time. So only just like final remarks that we need to look at our security model as Swiss cheese security model with those different slices of security. When one slice, stacking slices together, one slice covers the holes or weaknesses in another slice. And don't aim at 100% secure system. It's not possible. Instead, we need to make it very hard for bad guys to exploit or attack our clusters, and make the life of good guys, ourselves, easier to detect those attack attempts very early on. Remember, a fool with a tool is only a fool, so we need to use our tools wisely, and we need to configure our Kubernetes clusters and workloads wisely. It's all about continuous learning, so that's what conferences are all about. So hopefully you've learned something during this presentation, and thank you for your cooperation in my hacking. Thank you.